Okay, here we're looking at physical quantities in units, topic number 1. So these are just the guides to your notes. Okay, so remember they are to be done before class. Okay, so they're for prep, and you can use the things like this video to help you. At each topic you're going to get this sheet here, which is your learning outcomes. Essentially it's a good little summary of what you do need to know, and it's also got some important words. Now the first thing we're going to look at is what is a physical quantity. Well, we can have things like meters and so on, meters, seconds, they're all units, okay, and they're units that are associated with a physical quantity. So a physical quantity is a thing that you actually will take a measurement of. So anything that can be measured is a physical quantity. So temperature, density, electrical potential, physical quantities. But things that are pretty hard to quantify, then they cannot be a physical quantity. So we've got some examples there. Length being 50 meters and mass 20 kgs, two things that can be measured. Now they must always have a magnitude in unit. Mind you might find that some that we come across essentially turn into ratios, so they don't have a unit. What are base units? Now, essentially there are, in total, there's 7 base units. What do they actually mean? Well, they are essentially where all the units come from. They're where everything starts from in the beginning. It's sort of like, essentially a lot of units have all been made up, but when you come up with new things that we measure, they need to be related to other things. So there's 7 base units. We are going to use 5. Okay, and here's 6 of them. So time, length, temperature, current, and mass are all ones that we're going to use in physics a lot. Amount of substance you use in chemistry is not really used for AS physics. So what is the unit for time? The base unit, it is seconds. Okay, symbol for that, small s. Length is meters. Okay, small m. Temperature is Kelvin, capital K. Current is the ampere, capital A. Mass is the kg, kilogram. And the last one, the amount of substance, well, that's the mole. Okay, mole. But we'll leave that to chemistry. So any other units can actually be derived from this. If you ever want to find the unit for energy, well, it can be made up of base units. Anything you can think of that we measure, force, power, can all be made up of base units. Well, what are derived units? Well, like I said just before, you can find units using any units for anything. The amount of magnetic field strength or anything like that could be can have a unit created from those 5 base units or 7 base units. So that means that, for example, the joule could actually be created by using just base units. So let's have an example here. We've got charge. So what is the base unit of charge? Well, we know the SI unit is the coulomb. Okay, so that is the base unit, the SI unit, but we're trying to find the base unit for Q. So what we're going to do here, we're going to substitute the base unit for current, because that is what the symbol I stands for. I stands for current, and we know it's one of our 5 base units, so I can put it straight into the formula. Then I'm going to substitute the base unit here for time, okay, because that's a T. So if we put that in, we get an S. Okay, so the base unit for Q is AS, okay, amp seconds. If we carry on from there, we can have a look at another common equation. There we have velocity is equal to displacement, which is measured in meters, divided by time. So if I just grab this across here and this one, and we substitute in the base units for each of these terms, they're both part of our 5 base units, so it's quite easy. So if we just put in our displacement, which is meters, time, which is in seconds, and let's put that time to the top line, we get ms to the -1. So what is the base unit? It is ms to the -1. Now, the SI unit is usually named after somebody who's famous. In this case, they haven't done that for velocity, so the velocity actually has the same unit, SI unit, as the derived or base unit. So here's a bit of a trickier one. Work that's work there is equal to force times distance. Now force and distance, well, force in this case is not in our 5 base units. Okay, so we can't just substitute the base unit straight in there. For all derived units, we need to always use base units. So in this equation, we only know D, so that's okay, but we need to find what force could be in terms of base units only. So let's look for another formula for force. So force is equal to EMA. We'll know more of these formulas later on, so I wouldn't worry too much now. You'll know a lot of them by the end of the year. So substitute the new term for force into the work equation. So we get work is equal to MA, so that's what force is equal to. This section here is what force is equal to, and then we're going to multiply it by the D. We're keeping the D there because it's part of the equation, but it's also a base unit straight away. Well, it's a base quantity straight away. Now, unfortunately, we've now got, well, not unfortunately, but it's getting better. We have mass there, which is a base quantity. It's got a base unit associated with it. We've got distance, which has also got a base unit associated with it. But unfortunately, acceleration may be unknown to us in terms of base units. So finding that one, we use equation for acceleration. Now, acceleration is equal to velocity divided by time. Okay, we'll substitute that into the work equation. You get work equals mass times velocity divided by times multiplied by distance. Now, we already know the velocity derived unit from the last slide, so we'll substitute that into here for velocity. So I think we can actually put in units for this equation. So all the values in this equation, all the quantities in this equation, we can substitute in base units. So if we actually put them in, we could actually find the derived unit. So let's say for mass, mass is kg. We're going to multiply that by meters divided by seconds, and we're going to multiply that by another 1 over s. Okay, I might write that a different way now, and multiply that by meters. So another way of doing this, we could say that we've got kg multiplied by meters per second divided by seconds multiplied by meters. That's probably a better way. Now, let's simplify that. Let's bring this s to the top line. So we get kg ms to the -2 multiplied by m. Let's combine these two m's. So we get kg m squared s to the -2. And that is our derived unit for work. So let's put in our base unit or derived unit for work. It is kg m squared s to the -2. Now, what is the SI unit for work? Well, hopefully we all know it is the joule.